Hi class, this is Mr. Morris. We want to determine the intermolecular forces present for the compounds above. So we're looking at this table up here, and we want to rank them from the lowest to the highest melting point. So first we want to list our intermolecular forces. Well, I see that every single one of these has bonds in it, which tells us that we obviously have electrons. So there's one type of force that exists in everything that has electrons, and that is London dispersion forces, LDF. So I can go ahead and write LDF for all three of these. Okay. Now there's one of these, pentane, that is a nonpolar molecule. And it's nonpolar because you can see that it's a repeating chain. There are no lone pairs, and it's just two types of atoms. We have carbon in the center, and then we have hydrogens all around the edge. So it's going to arrange itself in a way where all of the dipoles that might be there cancel out. So that makes it a nonpolar molecule. Well, if it's a nonpolar molecule, the only type of force that exists in that compound is London dispersion forces. Then we get to butanol, this one up here, butanol. It has LDF, but it looks like it's got something else because I have a dipole right here. You see, oxygen is more electronegative than carbon is, so we've got a net dipole facing that way, and it doesn't cancel out with anything else. So that means we do have a polar molecule here. Looks to me like we have some dipole-dipole forces. Even though we have oxygen and hydrogen in the same molecule, there's no OH bond. Since there's no OH bond, we don't actually have hydrogen bonding. We just have LDF and dipole-dipole. Now let's look at propanoic acid. Well, I've got another one of those dipoles right there, and there's another dipole facing like that way, and you might notice these lone pairs that bends this molecule, so it's actually that would actually be sort of this shape. It's going to have a bent shape, so even though we have dipoles that are pointing towards the oxygen, their net dipole is going to be pointing up. So at any rate, you don't have to draw all of that. The bottom line is you can see that this is a polar molecule, so we do have dipole-dipole forces. But we also have an OH bond. Because we have an OH bond, we know that we have hydrogen bonds. Again, putting quotes around hydrogen bonds because it's a strong intermolecular force. So we have LDF, dipole-dipole, and hydrogen bonds. So just looking at that, I hope that you could identify which one has the strongest intermolecular forces if you were making an estimation. And it would be the one that has LDF, dipole-dipole, and hydrogen bonds. Now it asks us to rank them from the lowest to the highest melting point. Now lowest melting point means it's easy to melt, easy intermolecular forces to break. So that would be the one with the weakest or the least intermolecular forces. Looks like that's going to be pentane. Pentane has the lowest melting point. Then afterward, we're going to have the one that has LDF and dipole-dipole, which is butanol. And then finally, the one with the highest melting point is propanoic acid, or propanoic acid. And that is how you would answer a question like this, where you're supposed to rank the melting points or the boiling points based on the intermolecular forces that are present.